Hi everyone, this video is going to go through question number 6 from the 2017 AP exam. And so what you can see is we're going to be working with 3 different functions here, and each one has a different representation. So f of x we're given the equation, for g of x we're given a table of values, and for h we're given the graph. So let's see what we need to do here. So the first question, it says find the slope of the line tangent to the graph of f at x equals pi. So here they just want the slope of the tangent line. So what you need to know here is what they're really asking for is the derivative evaluated at pi. That derivative is going to give us the slope of the tangent line. So the first thing I need to do is figure out f prime of x. And so here I have an equation for f of x, so we're going to take its derivative. So my first term, I have a cosine, and I have a cosine of 2x, so I'm going to need to use the chain rule. So the derivative of my outside function, derivative of cosine, is negative sine. It's negative sine of 2x, and then I'm going to multiply by the derivative of my inside. Derivative of 2x is just 2. Plus, I've got e to the sine x, so it's going to be e to the sine of x, and again, I'm using the chain rule. The derivative of sine x is cosine of x. So now I'm just going to evaluate that when x is pi. So f prime of pi is negative sine. If I plug in pi for x, I get of 2 pi times 2 plus e to the sine of pi times cosine of pi. So let's see. Sine of 2 pi is going to be 0, so my first term goes away. I have e to the sine of pi, again that's e to the 0, times cosine of pi, and cosine of pi is going to be negative 1. So e to the 0 we know is 1, so 1 times negative 1 is negative 1. So f prime of pi is equal to negative 1. And so here they're giving 2 points for the answer. Okay, for part B, it says let k be the function defined by k of x equals h of f of x. And they're asking us to find k prime of pi. So I'm going to find k prime. Here I have a composition of functions, so this is going to require chain rule. So I'm going to take the derivative of the outside first. So I have h prime of f of x. And then I'm going to multiply by the derivative of the inside, so times f prime of x. So now I have k prime of pi. I'm going to substitute in pi. So I have h prime of f of pi times f prime of pi. All right, so let's see, what do we know here? F of pi, I actually need to figure out. So f of pi, I'm going to use my definition here, is going to be cosine of 2 pi plus e to the sine of pi. So cosine of 2 pi, that's going to be 1, plus e. Sine of pi is 0, e to the 0. E to the 0 is 1, so 1 plus 1 is 2. So now I've got h prime, f of pi is 2. F prime of pi we actually found in part A, that's negative 1. Now h prime of 2, here we're going to have to look at the graph of h. So here, and I know h prime of 2, they want to know what is the slope of h when x is 2. Well, since this is linear, we can just take the slope of this linear segment, which is negative 1 over 3. So I get negative 1/3 times negative 1, and then I know k prime of pi is equal to 1/3. Oops, I'm sorry, you couldn't see that there. There we go. As far as scoring for this one, they gave 1 point for the derivative and then 1 point for the final answer. All right, for part C, and I'm sorry you can't see the question at the same time here. Actually, let me do this. I'll fold over my paper so we can see. Okay, so now for part C, it's giving us a function m, and it says m of x equals g of negative 2x times h of x. And we want to find m prime of 2. You can see this question, it's really heavy, it's really heavy on these derivative rules. So m prime of x, here I have a product of two functions, so I need to use product rule. So that's going to say I'm going to take my original function times the derivative of the second, so times h prime of x, plus, I'm going to take the second one as it is, h of x, times the derivative of the first, remembering my chain rule. So it's going to be g prime of negative 2x, and then times negative 2. So now m prime of 2 is equal to g of, well, if I substitute 2 for x, I get g of negative 4 times h prime of 2 plus h of 2 times g prime of negative 4 times negative 2. All right, so g of negative 4 I can just get from my table. So g of negative 4 is 5. H prime of 2, right? Again, h prime of 2 is that slope when x is 2, and we found that was a negative 1/3. Plus, now h of 2, we've got to be a little careful with. So h of 2 obviously isn't some nice value. So here's where we're going to use what we know about this slope. This slope was negative 1/3. So I know for each time I go over 1 on the x-axis, I'm going down 1/3. So if I go over 2, I'm going down 2/3. So this point is going to be 2, negative 2/3. So now I know h of 2 is negative 2/3. G prime of negative 4 is negative 1, and then I've got my negative 2. So if we simplify, we get negative 5/3. This is going to be minus 4/3. If I simplify, I get negative 9/3, which is just negative 3. Here it was 2 points for the derivative, so demonstrating that you know what the product rule is, and then 1 point for the answer. Okay, the last question here says, is there a number c in the closed interval from negative 5 to negative 3 such that g prime of c equals negative 4? And then I want you to justify your answer. So here's what hopefully you should recognize. Since they're asking you to guarantee the value of the derivative, that should make you think about the mean value theorem. Whenever they're asking you if there's a number, they're guaranteeing a value of a derivative. That's your mean value theorem. So remember, to use the mean value theorem, we have to show that our function is differentiable. Excuse me, it's continuous and differentiable over the interval. Well, they told us here that our function was differentiable. So if it's differentiable, it had to be continuous. So what I would say is, since g is differentiable, it is continuous on that interval from negative 5 to negative 3. Now remember, the mean value theorem told us that the average rate of change should be equal to the instantaneous rate of change. So what I'm going to check next is the average rate of change over this interval. So I'm going to calculate g of negative 3 minus g of negative 5 all over negative 3 minus negative 5. Using the table, I get g of negative 3 is 2, g of negative 5 is 10, and down here I get 2. So negative 8 over 2 is negative 4. Oops, I'm sorry. Let's move that up. All right, so we showed that the function was continuous and differentiable. We showed that the average rate of change was negative 4. So once we have these two things, we can say, therefore, by the MVT, let's see, and here, right, I would use the wording of the question. It says, is there a number C in this interval such that G prime of C equals -4? So I'm going to use that same wording. I'm going to say by MVT, there is a value C in the interval from -5 to -3 such that G prime of C equals -4. So since it's continuous and differentiable, mean value theorem tells me that at some point the average should be equal to the instantaneous. So since I showed that that average rate of change is -4, I know that at some point the instantaneous rate of change should also be -4. So for scoring for that one, they're giving you 1 point for calculating that average rate of change, and then 1 point for the justification. And you have to make sure that you cite mean value theorem there to get credit. Otherwise, you will not receive credit for that justification. All right, that's it for this question.